So this is a tutorial, the second, probably actually the first tutorial for TensorFlow, and it's presented on the TensorFlow series. I'll link in the description, or I'll provide a link in the description. So this is kind of like the most basic example, I guess, you're kind of a hello world of machine learning. So, and I'm using Colab, or whatever it's called, Colab, Google Colab, because it's free, it's easy, it's all set up, your environment, you don't have to do anything on your own laptop. So, and plus mine's out right now, so I'm using my phone. So that's why we're getting a screenshot. And I've started these tutorials, and I just wanted to kind of review them with you guys, because it helps me to learn as I kind of instruct or teach. So basically we're using TensorFlow. And this is the simplest neuron, single neuron, single layer model that exists in TensorFlow. There's some other technologies that I've used before that are actually just JavaScript that kind of delineated the stuff in like 4 or 5 lines of very easy to read code, like the simplest model, and you could see it do backward propagation and all that. So this kind of wraps up all those functions, so you still have to kind of learn TensorFlow for its own way. So so you're importing TensorFlow. You see it's a little bit of code I'm using in Colab, and you're importing NumPy, which is Python's library for handling arrays and numbers and things like that. And then we're importing Keras, which is a data set, I think, or I want to say it's part of the model. I have to find out more about Keras. It's part of the model, but it has its own data set. So once you've instantiated the model here by using TensorFlow Keras sequential, and sequential means that you're going to have these layers, these Keras layers in sequence, and these Keras layers provide a density function that allows you to tell it how many neurons. In this case, units equals neurons, so 1 neuron, and the input that we're going to give it is just one single value, rather. I was looking for something else that was supposed to be happening. Either way. Okay, so then down here this is all copied code. I didn't write any of this. So here we're establishing the y and x parameters, or x and y parameters. So this is really y equals mx plus b, and in this case it's going to be y equals 3x plus 1. So let's see, again, the model is just a trained neural network, and that's what we're looking at, the simplest model. And you can see by these numbers that that's what we're not going to give it the formula. We're going to let it give us figure out the formula on its own. And for example, if you see the 4 and the 3 here, if you take 4 and multiply it times 3, which is 12, and you add 1, then you get 13. So that's, whoops, sorry, lost it. So that's what we're going for. And it already works because it's already been ran. So after you established your data, which is just a few numbers here, when you fit the model, you run the fit function on it with the data, the x values, y values, and epochs tells you how many times you're going to try to fit those values. So it's going to come back using this compiler optimizer and loss function. We're giving it some values, looks like some constant values to tell it what type of loss to use. For example, if the number is not correct, because we give it the answer. So if the number doesn't match the answer, it takes the error, the difference of the error, and it applies it. Then it runs back over to the optimizer, in this case SGD, which is others. There's sigmoid and so forth, but this is SGD stands for stochastic gradient descent, I believe. So that's just the way it's going to try guessing. Stochastic means it's a fancy word for guessing. So it's going to guess a different number and pass it to it, and we're going to try it 50 times as per the epochs here. So we have this, we have the data. One last thing I had to do was, when it ready to print out the prediction, on the tutorial that I'm going to leave a link to, it doesn't have the NP array right here before it passes in that 10 value. And so I had to kind of go research and figure that out. So that's it. We'll just run it real quick. So I'm gonna run this down, and sorry I had that up the whole time. So here it's running. It's instantiating the model. It's compiling the model with the optimizer. Now it's fitting the model. It should start showing the iterations. And there they go. So we said 500 epochs. And you can kind of see, counting down there. It's 130, 140, 160 out of the 500. When it gets to 500, it stops. So that's just how many times it's going to try the backward propagation, the optimization, the error, applying the errors to the answers that we've given it. And it probably doesn't need 500, but this is probably what they show for an example. So here we go. We're at the bottom. Whoops. Trying to get to the bottom. There we go. And so we put in the number 10. So if you multiply 10 times 3 and add 1, that's 31, right? So 30.9 is 31. It's, for all intents and purposes. I call it fuzzy logic, and it is, but it's built in for a reason, because it's working on stochastic algorithms that haven't really taken every infinite possibility into account, and so it's going to give you this it's usually a percentage. Sometimes it's a percentage of yes or no, but in this case it just gives you kind of rounded up or rounded down to the answer, 31. And we look back over here, if we can get back up here. We inputted to print the model, predict NP array. Let me get over here. I can. And we just fed it the number 10. So yeah, 10 times 3 plus 1 is 31. And that's the answer it gave us. So we can run it again. It probably gives us a different answer, but always really close to 31. I like to, you can change these numbers around. So I have some notes here. Over here, let me move this up here again. So you can change these numbers around to do any kind of other linear graphing, or any other vectors on the Cartesian plane rather, and or stock prices, stuff like that. So whatever, you could always start using this for everyday problems. I think you can come up with ideas. But this is the very first lesson, and it's the simplest model. It's by the time you get down to here, or right after that line, this is a trained model, so you could just reuse it. So that's it for now. I think that's all I had. Yeah, when it's doing the fit right here, this actual function right here, that's when it's actually running this optimizer and the error. If it guesses, if it does 5 times 3 plus 4 or something like that instead of the actual formula, which is 3 times x plus 1, then it'll try something else based on what this optimizer is doing. And the optimizer it's using, I guess it's this constant SGD, which stands for stochastic gradient descent. Can you remember that? Okay, and I want to find out more things about the sequential part of, well, not necessarily that, but the Keras, because I thought the Keras was the actual data set, but the data set just comes with it. And we'll talk about the data set. It's in the next lesson. So I'll link all this other stuff below, but that's it. Thanks.